Hey guys, in this video I'm going to be doing two lessons. This first one is Math 2 9-3, Unit 9, Lesson 3. This is literally just the Pythagorean theorem, which is this, where we have a right triangle, and with the right triangle, the side opposite of the right angle is our C, and either of these can be A or B. It literally doesn't matter, but A squared plus B squared equals C squared. This is probably the easiest lesson because I'm going to literally have like two examples. So first of all, we have our first triangle, and let's say we have 6, 12, and we're trying to find our C value. We're also using like the roots and radicals from the other lessons. So there's, I guess, it's just there's that sort of extra part to it. But yeah, so let's take, now we're literally just plugging in A squared plus B squared equals C squared. So for this, we have 6 squared plus 12 squared equals C squared. This is just 36 plus 144 equals C squared. 36 plus 144, I don't know what that is. 4, 3, I think it's 180. 180 equals C squared. I need to look that up real quick. Okay, I better not be wrong. Let's see. 36 plus 144, that is 180. So 180 equals C squared. Now, we just square root of 180 equals C, because the square root of C squared is C. And you just square root both sides. So square root of 180 is C. What is the square root of 180? It's definitely not even. Let's try this. 9 and 20. This is 3 and 3 because 9 is a perfect square. For 20, we have 10, 2, 5, and 2. So we have a pair of 2s and a pair of 3s. So that's just 2 times 3 equals 6. 6 root 5. And that should be 36 times 4. Yeah, okay, so this is what we have. This is our answer, 6 root 5. If you don't know how we got there, we have a pair of 2s, a pair of 2s, and a pair of 3s. And then we take both of them out of the radical. 2 times 3 equals 6. And in the radical, we still have a 5. So it's 6 root 5. So our C equals 6 root 5. And that is literally it. That is this entire lesson. I'll do one more problem just to make sure you guys understand it. I'll go a little slower this time. We have 12 and 10. And we're trying to find our C value. This time we have 12 squared plus 10 squared equals C squared. This is 144 plus 100 equals 2. C squared. And then we do 244 equals C squared. And the roots of 244 equals C. Okay. Root 244. We go 2 and 122. I don't know if you guys saw my other video. But I was trying to make an example. I have the paper right here because I'm doing this all on the same night. I was trying to find examples of when you have multiple tubes and you don't just have 4s. If you don't know why, don't worry about it. But I was trying to do that, and it wasn't working out very well. So anyways, we have our example now. 2 and 122, and then we have 2 and 61. From my understanding, 61 is prime. I'm going to look that up just in case. Is 61 prime? Prime. 61 is prime. So we have the 2s, and we take the 2 out, and we leave the 61 inside. And our C value is just 2 root 61. And that's it. That's literally the entire lesson. So because of that, I'm going to also fit 9-4 in, which is also really easy. Okay, let's do one of these problems. We'll do square root of p minus 1 plus 1 equals p. This is 9-4. The only thing that you really need to know are these two equations, which I will write over here. A plus b squared equals a squared plus 2ab plus b squared. And then a minus b squared equals a squared minus 2ab plus b squared. Go ahead, take a picture of that, screenshot, whatever you want to do. That is what you need to know. And yeah, that is basically it for this lesson. But we'll start with this really seemingly difficult example. How many more examples can I choose from? Oh, not that many. Okay. So, there's actually something you can do here. There are a couple ways to go by this, but we want to get rid of the square root. So by getting rid of the square root, we have to just square the number. However, let's not do that yet. We can wait. So we can, first of all, we don't want any hanging numbers like this. We want all the numbers to be with a variable. If you don't know what that means, I'll explain it to you after I do this first step. I'm really not comfortable where I'm sitting right now. Okay. Okay, so we have, just take away 1 from each side. That is not stable. Get out. Okay. Oh, it's because of my wallet. Okay. We have, take away 1 from both sides. And then our new equation is root p minus 1 equals p minus 1. And there are actually a couple, there's 2 answers for this. We'll get there in a little bit. But now, this is our new problem. Now, we want to get rid of this square root because otherwise we can't solve this problem. So we square both sides. And now we have the square root of p1 times the square root of p1, or p minus 1, which is just p minus 1. Now, to this side, we have to go p minus 1 squared. For this, I would do the area method, or the box method. I don't even know what it's called. I don't know the name of the methods. I know what they are, though. P1, and we have negative p squared, 1. And so p minus 1 equals p squared minus 2p plus 1. And this is our new problem. This should be pretty familiar because very early on in the year, we were doing equations like this. Focus. We're doing equations like that and that. And now when we come over here, it's literally the same thing, but with like square roots. Anyways, so this is what we have right here. This is our new problem. Now, we want this side to be 0, so that way we can do the quadratic formula, and we have our 2 factors that equal 0. I think I can find this in our earlier notes, actually. Let me try to find it right now. Oh, never mind. Those are all graphing stuff. Well, I don't know if you remember, but we would usually have equations that it's like this. It's like x squared minus 3x plus 4 equals 0. Right? We'd have stuff like that. So that we're trying to get that with this equation now. So what we do is we take away p and we add 1. And doing that, we get 0 equals p squared minus 3p plus 2. After this, we can do our x method. Diamond method, I think, is what this one's called. 2 and negative 3. Because it's A, C, and B. Our B value is negative 3. Our A is 1, and our C is 2. Why is there A 1? Because there's literally nothing there. So when there's nothing there, there's no like number accompanying the p squared. So it's just 1. That is an ugly 3. My apologies. But yeah, anyways, 2 and negative 3. And I believe this is negative 2 and negative 1. So now our 2 values are p minus 2 and p minus 1, which should look very familiar to you guys. And after that, we just do p minus 2 equals 0 and p minus 1 equals 0. And our p values are 2 and 1. And these are our answers. And when you plug them back into the equation, which you have to do, for reasons I will explain later, in a later lesson, because right now I don't think I can really exactly prove that. But you have to check that your p-values make sense in the context of the problem. If we have p equals 2, our new problem is 2 minus 1 plus 1 equals 2, or the root of 2 minus 1 plus 1 equals 2, because we substitute p for 2. Right here, this makes sense, because 2 minus 1 is 1 plus 1 equals 2. Root 1 plus 1 equals 2. That makes sense. Now, if our p-value is 1, we would have root of 1 minus 1 plus 1 equals 1. This also makes sense, because the square root of 0 plus 1 equals 1. And the square root of 0, as we all know, is just 0. And 0 plus 1 equals 1. And yeah, that, like, both of these work. Both of these are true. Both of these p-values, they work and they're true. And therefore, those are our answers. And yeah, that's literally it. I can show you one example, and that's practically all you're really gonna need. But yeah, if you need more examples, I'll do more examples. I'm just really trying to go do other stuff. You know what? Actually, I'll show you guys one more really easy one that I have looking at right here. Square root of 2x minus 1 equals 7. We want to get rid of the square root, so we square both sides. 49 and 2x minus 1. Because the square root of 2x minus 1 times the square root of 2x minus 1 is just 2x minus 1. And then the square, and then 7 times 7 is 49. So now we have 2x minus 1 equals 49. 2x equals 50 after adding 1 to both sides. X is 25. Oh gosh, x is 25. And that is literally it. Those are by far the two probably easiest problem sets, which is why our classes are ahead. But yeah, those are the two lessons. If you'd like more examples or more elaboration, text me on Remind, post something in the comments. If you have my number, just text me. I'm available. But yeah, that's it.